Awesome. Well, we will get started. Thanks. Great to see everybody. I am very excited to be here at this very first virtual Code PaLOusa. This is my, I guess, 9th consecutive Code PaLOusa to attend. So it's been just a great conference, and I'm really excited to be here. So I hope everybody has a great time. First session this morning went really well. So I hope this works well for everybody. So I am going to get started on it. So from monolith to serverless, based on the title of this talk, you may imagine that I'm going to explain how to migrate from a monolith architecture to a serverless architecture. And that is, in fact, kind of what I'm going to do. And it might sound like a technical talk with exact details on how to make this change, but that's a little bit less what I'm going to cover. There's a lot of technical details. There's a lot of different platforms and systems, and it's really hard to get into all the nuts and bolts of the technical details of doing this sort of thing. So what I want to talk about is the concept and approach and how things change. So instead of discussing the technology involved in moving from more of a monolith mindset to a serverless mindset, I want to talk about my own journey and lessons that I've learned as an architect from moving from one of these paradigms to the other. My name is Michael Dowden. I'm CEO of Andromeda. We build and operate software products and similar services for our clients. And for more than 20 years, I built monolithic and monolithic and service-oriented applications. For the last 5 years, I have been primarily designing serverless applications. And what is missing from this timeline is really the time that I spent climbing the learning curve. So what's coming next is the story of what happened from that experience. It's my story to try to illustrate my learning path, because I feel like a lot of developers have gone through a similar type of journey as we try to adapt to this new technology and this new mindset. And hopefully it'll help frame the context for how I think about serverless architecture, which is how we'll wrap up this talk. So as we get started, please feel free at any time to ask questions. I will monitor the chat. I'm happy to interact with you. Feel free to share your audio and video if you would like to, and we will get started. So because this is a talk about architecture and approach, I think it's a lot easier if we work from a concrete example rather than talking in vague and general terms, right? So this will help to anchor the concepts that we're discussing. And so for this presentation, we're going to use a toy store. So this is an example page from the application showing a list of products. And no, I would never actually design an app that looked like this, but for demo purposes, it's really convenient to have multiple different areas of the application showing on a single page, so I have just one thing to look at as we're talking about it. So as we look at the screen, what are some different product requirements that we can derive based upon what we're looking at? So one thing, we're going to have authentication. People are going to need to be able to log in. So they're going to have user accounts, information we have to track. There's a list of products that we need to be able to show. We want to show product details and probably allow people to order those products. Because of that, now we need a shopping cart, and we're going to have other payment details. So that'll do for now. We're going to cover these specific requirements as we look at the different areas of the application. There we go. So let's take this toy store example and construct an application design. So I'm going to show you not what I would do today. I'm going to show you how I might have approached this problem 15 or 20 years ago. And believe it or not, I've actually seen applications follow a similar approach even recently. So this is not an atypical way of approaching a software architecture. So here is a quick peek at the paradigm that we're following. All the work in this situation happens on the server, and then the view is sent to the client, which in our example is going to be a web browser. But in the case of like a monolithic desktop app or even a mobile app, technically all of this could run on a single client device and still be a monolith. But in our web-based situation, we're going to look at this as a server, and then we run code on the client. And actually, in this case, we're not even running code on the client. We're just displaying the view. And the first thing I'm going to start with here is a data model. A lot of times, this is how we're going to get started on designing a new system. We're going to think about what are all the different entities that we need to track, what are some of the attributes that we need to keep track of in these entities, and we're going to build an entity relationship diagram like this, and we're going to describe the relationships between these different entities. Some other things that I should have probably included on here, right? As we build this out, we'll need to come up with the product, maybe product categories, payment details, user accounts. These are all the types of data that we're going to need to be able to track for this system. Once we have put together our entity diagram, now we can start to build the software diagram. What classes I'm going to need in the software? How are those going to map to those entities that we're storing in the relational database? What packages are we going to need to store these different classes? What does that structure look like? And when we're done, we're going to have a view of what our object model is and what the code is going to look like from a structure standpoint. And then there's going to be areas of the application that have different processes that we need to communicate between our business stakeholders and our developers. So lots of ways of doing this. We can write out use cases. We can build flowcharts like this. We can do activity or sequence diagrams, but somehow we need to define and describe the actions and activities that are happening within this application, right? And this is just one quick example when somebody clicks the Pay Now button. And once we've described all this functionality, now we're going to put together wireframes. We're going to need to be able to illustrate, well, what is the UI going to look like? What do I want to actually send to the client device so that somebody can interact with this application? And we're going to put wireframes together to be able to do that. And once we've done all this, we're going to have a tech stack, right? There's all these different roles that we need to fill in our tech stack, and we need to make decisions. So we're going to come up with specific technologies to fill this out, and we're going to make a decision. Maybe this is going to be Linux-based. We're going to use Java. It's going to run an Internet Explorer. Hey, I told you this was, 15 years ago, right? But we're going to come up with a stack like this, and these are the different technologies we're going to use, and that's going to help us make specific decisions about how we implement this project. And once all these technical details are done, we're going to take it into a meeting with our business stakeholders, and we're going to present and review technical documentation and diagrams until their eyes glaze over and they agree to whatever we say, right? Okay, no, not really. But this is the point at which disconnects happen, right? We've done all this technical work, and we've done it theoretically so that we can get sign-off, so we can get feedback, so that we can make sure we're building the right thing. But it's really hard to do that based upon this documentation. And UML, for example, UML is, sometimes I think you might need to go to school for nothing but learning how to build UML diagrams. It's complicated, and reading them isn't always straightforward. And I hear you saying, no, wait, this isn't how we do things. We use Agile now. Yeah, and I'm sure you do. But lots of companies build software in layers like this and dump all the requirements into 1 or 2 meetings, even if they're using Scrum, for example. There's a lot of projects that suffer from the same flaws as waterfall projects based upon the way they approach software architecture. And so we'll touch about this more as we move along. But also remember that this is an example from my past, and sadly, 20 years ago, this is probably how I would have done it. Hopefully I've learned a thing or two since then. So once we're done with this architecture and we build the software, this is kind of what we have. Our user is from their device or their web browser, they're going to issue get and post requests over HTTP to the monolith, and they're going to get HTTP responses back, which is generally going to consist of nothing but HTML or maybe some HTML and CSS and a little bit of JavaScript. And so all the details that we just painstakingly diagrammed and documented for this product now live within the walls of this monolith. It's just this box. And from the perspective of the user, from the perspective of our DevOps or our operations team, that's what it exists. And only the developers really get to look under the covers of the code and understand the structure and makeup and composition of this application. That's the result. So if you read the abstract, you probably realized that I promised you a walkthrough of service-oriented architecture. And you're absolutely correct. So I started from the beginning and walked you through our monolithic waterfall, but now let's look at perhaps a more common approach these days. When we look at a tech stack like we just built, well, one approach, a traditional approach, is to go bottom up, right? And that's what we walked through. I went all the way from the bottom, the data layer, all the way up to the view, and then we documented it in that order. That's not all that uncommon. We can do it the other way around, right? We can start by designing our views and then eventually figuring out what our data needs to look like. Another option, by the way, is to go from the outside in. We actually build our views and our templates, we design our data, and then we kind of meet in the middle. And honestly, that's what I used to do a lot of when designing software. And totally fine approach. Another way of kind of dividing this up is to go in vertical slices, right? We want to do all the work for a single feature, all the way from the servers to the client and everything in between. And we want to do these in chunks. And there's a lot of advantages to this, especially for Agile. This is a great way to work as an Agile team. It allows everybody on the team to be involved. It makes sure that you're able to produce one thing of value that's a cohesive unit, get it out to the user, and then move on to the next one. So I feel like this is the way a lot more teams work now in vertical slices. But even within that vertical slice, there's going to be some of this action going on, right? We're going to kind of decide, we're going to start from the top or the bottom, and we're going to design the systems. So with that context, here's how the architecture is going to change a little bit. The logic, the business logic, the code, the data, that all exists on the server. But a lot of times in a service-oriented architecture, we're exposing services, and then a lot of the code that the user will interact with exists in a view on their device. It doesn't matter if that's JavaScript that runs in a web browser, if it's a mobile application, if it's a lightweight desktop application that still uses HTTP services to do a lot of work. Lots of ways this can happen. We use these sorts of applications all the time. What we've been calling a view, though, in this situation is perhaps better called an app, right? So we have desktop software, single-page web applications, progressive web applications, mobile apps, IoT devices. IoT devices run code on a device, like all of these do. And in most cases, these apps are responsible for the user interface. They may also handle the majority of the application logic in some cases. Sometimes the application logic happens, a lot of that on the server, sometimes some of it happens on the client. But knowing where to draw that line, it's not straightforward. It's not the same for every application. Knowing where to draw the line between what belongs on the server, what belongs in the client, is a job for the software architect. That's one of our responsibilities. It's something we have to make a decision on. And security, data integrity, performance, scalability, these are all things we have to consider when making that decision. Yeah, even game consoles, right? That's another example of some place we might run code. So we'll need to do much of the work we did before, right? We need to design our user interfaces. We need to design our databases and our entities. We need to design our software packaging model. And a lot of times, if we're dealing with code in vertical slices, we're doing one function at a time, top to bottom. We may peek ahead at future features while we're doing some of this work. We want to make sure that we're not painting ourselves into a corner as we're designing our databases, designing our data structures, and those sorts of things. But of course, there's one big thing that we add in a service-oriented architecture, and that is services, right? Once we have a data model and class diagrams, we need to define the services we want to expose to our applications. And we call those APIs generally. And the way we select and define these APIs and how we implement them will determine the types of apps we can build, the features they can have, the user interfaces we can construct, and it will influence their performance in some ways. So this image illustrates an API diagram by showing the interface between a barista and a customer when ordering a latte, right? And we can design interface diagrams for all kinds of human interactions. We're going to do the same thing for APIs. So this is just an example, and it works. Once we have completed a feature from back to front using this approach, we now have something of value that we can actually put in front of stakeholders and end users for review. We can let them use it. We can let them see it and hold it and touch it. And they can start using our product and getting value from it while we continue to build new features. And this is something that's not possible when we build exclusively in horizontal layers. And by doing things in this horizontal approach, this vertical approach instead of horizontal approach, we move faster, we get more feedback, we get better feedback. And once we have sufficient APIs, the people building our applications, our front-end developers, our mobile developers, they can have the freedom to envision new and different functionality and user experiences based upon the same set of data interactions that we've created, right? They can think about things in new ways. They can do UX reviews and meet with the customer and make changes. And so long as they're still dealing with the same data, they can use the same APIs and make those changes. And so we're really empowering the user experience with these sorts of differences. So this is a very powerful approach. It's a powerful architecture for being able to meet the users where they are. So once we have one or more apps that interact with our API using HTTP, a lot of times we're going to use REST-based protocols. Sometimes we'll use SOAP. Other mechanisms exist. There's no wrong answer to this. But our product documentation, the things that we have designed, live in a variety of places. Some in our apps and devices, some of it in our APIs and the services that power them in our database. And so we still kind of have it's not really a monolith. We've broken out a lot of the user interactive part of the application, so that's valuable. And through our APIs and our services, we've exposed access to some of the things that are happening. So now our operations teams, for example, our DevOps teams, they now have a little bit more visibility into what's going on. They see the endpoints, and they have a little bit better awareness into the nature of the application we're running. And the client application can evolve and can scale completely separately from the backend code. And so that's something that we've achieved with this sort of architecture. And so I've built a lot of software this way. But as we journey on to serverless, I'm going to do another small interlude. Microservices is a big topic. And so let's delve into really briefly how microservices interrupt maybe some of these architectures. So this is one view of a microservices architecture. And sometimes you'll see the data in a silo combined with the individual services. Sometimes you'll see it as a shared data service like this. Sometimes it'll be implemented both of those ways. It doesn't matter. The idea here is that you are really breaking your API services out into smaller units, very small units. And interestingly enough, this is the one architecture I've really never actually built a microservice architecture. Variety of reasons for that. There are strengths and weaknesses of microservices. And so once we've built something in a microservice architecture, honestly, it's very similar to the service-oriented architecture. The architecture is honestly very, very similar. What's changing here is the way it's broken up. So now we have individual APIs and data that can be deployed separately and individually. That means our DevOps team has some flexibility to scale how we choose to scale things. We can scale things service by service. That's really valuable. And it doesn't really change anything for our user. It really doesn't change a whole lot about our code. The details here are very technical, less on the conceptual side, more on the technical side. There's a lot of technical differences between a monolithic service-oriented architecture and a microservice architecture that you're going to run into. different challenges. But conceptually, there's still a lot of similarities here in how we're going to build things. We're still building services that we're exposing to our users. How we choose to break that up can impact how we manage, how we monitor, how we make updates and changes, and potentially even how quickly, what the performance is on those APIs. So finally, we've broken down monolithic approach, service-oriented architecture, microservices. Let's look at how things change when we move into the serverless architecture. How are we going to approach this application? And the first thing I need to do is discuss what I mean in this context by serverless. Generally, what I mean by serverless is going to be a cloud-backed platform that scales dynamically by function rather than by module or package, where you only pay for what you use. That's, I guess, in a wrap up. So it really has a lot to do with how the thing scales, the fact that it's cloud-based, and it's very small and dynamic. And more specifically, when we look at serverless platforms, there's three common things that come to mind. The first is functions as a service. In fact, sometimes you'll hear functions as a service used almost interchangeably with serverless, although serverless is a lot bigger than just that. But that is the idea of a microservice architecture where it's so small that individual functions are deployed and scaled individually. Then you have backend as a service, which can be platforms like Firebase. There's a lot of different platforms on Amazon and Azure. You may have a database that is served as a backend as a service where the database scales automatically without you having to mess with anything. You don't have to worry about it. You only pay for the bits of the data that you store, the transactions with the database. So that's a backend as a service. That's one option for serverless. But another one that gets ignored a lot is, quite frankly, third-party services. If I'm using a public API and they're providing some level of guarantee that the level of scale that I need to reach is going to be covered, if I'm only paying for how much I use of that service, then it really counts as a serverless platform. I'm not having to manage or maintain any of that. I just use it, and they make sure that I'm able to use it successfully. And in many cases, increasingly, we're seeing third-party services implemented on either a backend as a service or a front-end as a service, meaning those third-party services are themselves depending on some serverless technology. So we can really dog food that sometimes, and it works really well. What this means is that our apps are based upon SDKs, software development kits, and APIs to these different services. And whether we've built those functions or those services, or if we're using somebody else's functions or services, we can build apps now that incorporate all these different features. And to me, that's really powerful. So we can build a representation of this serverless model that looks something like this. So where we started at the very beginning, everything was together. The view, the logic, the data, they were all together running on the server in one big monolithic module. Now, in serverless, we may have multiple small data sources. We may have lots and lots of functions that are deployed. They may have their own interactions in addition to the way they interact with our applications that run on the client. And so there's a lot of things going on, a lot of complexities, but also a lot of power. So how we manage some of that complexity is going to be very important. So when we build something on a serverless architecture with all this complexity, honestly, we can just deploy these as individual units, right? We isolate our functions and our code. So instead of one big box of things, we have lots of little individual things that we can deploy. We have our HTTP communication with each of those individually. So long as those are deployed on a serverless platform, congratulations, we're serverless, right? It's basically microservice architecture deployed to a different platform, managed in a slightly different way, and we're there. But this isn't really a paradigm shift. I do see a lot of people start their journey into serverless by doing this. And there's absolutely nothing wrong with that. this is a totally fine way of getting into serverless, and you're going to experience some benefits from doing this, especially if you're coming from a microservice architecture. It's a logical next step in how you might want to manage your infrastructure. But I also feel like serverless has a lot more to offer than this. So here's an alternative view. In this case, we may connect directly to a database using WebSockets. Maybe that database has triggers that run code. We may use a PubSub message queue system that we can read and write to. We can subscribe or we can publish, and there's code associated with the different actions there. We can still have our HTTP endpoints, right, our APIs. So there's a lot of different types of services we can take advantage of straight from our client apps in a serverless architecture, and we can do some really interesting interactions between those things themselves. So this is going to be a lot more the type of serverless architecture that I'm going to look at when I'm designing something. And part of the reason is, why would we focus exclusively on rest when our data doesn't rest? Our data is in motion. A lot of applications, data is constantly moving and changing. There's a lot of things happening. And in some cases, to be able to manage that constant motion of data, we simplify or even aggregate this type of activity, these changes, through batch processing. We may use ATLs, we may do nightly processes, we may do other things to propagate these changes. And there's nothing wrong with that. We can do those things, but that's not how I think of serverless. I don't think of batch, I don't think of rest. I think of things in motion and activities that are happening all the time, and the fact that we're able to actually manage this a lot more easily in this architecture than we could before. So when I think of serverless, I think of events. I think of functions with clear pre and post conditions. If you're doing functional programming in your applications, then I think that moving into a serverless paradigm is going to be a lot easier for you. If you're primarily doing traditional object-oriented design and development, it may take a little bit more mental gymnastics to get into this very fluid, event-driven way of thinking. You may have triggers such as database changes. Maybe somebody signs in, they sign out, their permissions change, these authentication triggers. Maybe we want to respond to those with code. We have messages from a message queue, a specific date or time comes in. We have cron jobs that will trigger activities. User activity, the user interacts by typing something, submitting a request, whatever that may look like. We want to be able to respond to these things and do things. And most backends as a service options will give you a variety of these types of services to take advantage of. They'll have message queues, they'll have SQL databases, they'll have NoSQL databases. You'll be able to deploy your functions to the cloud to respond to a variety of these triggers. So explore your options. Most of my functions that I write in a serverless world respond to these events and are not REST-based services. So for example, it would be pretty typical for me to have the client application write a record directly to a database and then have a trigger on that record showing up that runs code that does stuff, as opposed to the client calling a REST-based API and that REST-based API then writing to the database and doing stuff. It removes part of the barrier to the client application and gives us a lot more flexibility to how we change things up in the future. It gives us a lot more composability to our systems. And so there's going to be situations you don't need all of these things. There's going to be situations where you want REST-based services, but it's not my go-to anymore. I don't primarily think in terms of a REST-based API when I'm building systems anymore. So let's look at the Toy Store page again. Let's make this concrete again. Let's consider how this application may communicate to our services. So when somebody clicks Buy Now, we can write that value directly to a database, right? All we do is we'll click Buy Now, a record gets added to maybe a shopping cart. table. Now that shopping cart table, that shopping cart component that exists on the client, all it's doing potentially is watching that shopping cart, that user shopping cart record in the database, and as things get added to it, it's pulling those in and displaying them, right? This can be completely asynchronous. And we don't necessarily need to tie these two bits of code together because they both have a job to do. One's job is to write to the database, the other is to read to the database. And by implementing it like this, the really cool thing is the user, let's presume they're logged in, they can pull up their phone. They can do this work. They can order a product. They can add it to the cart on their phone, and then they pull it up on their desktop because maybe they just don't feel like typing their payment information on their phone. They want to do that from a keyboard, and they pull up the website on their browser, and the shopping cart's there, right? Because the job of the shopping cart is just to pull in whatever's in the database whenever you load this view. And it just works because that's the way we've designed it to work. And it's worth noting that when we're building systems like this, we don't actually have to necessarily go to the database. We could use SQLite in the browser. If we decide we don't care about the user's cross-device experience, what we care about is that it can work offline really, really well. Maybe we do the same type of thing, but we do it right within the browser. That's totally a possibility. So when somebody clicks Pay Now, maybe we want to take that, just send a message to message queue with the information necessary to complete the transaction, and immediately take them to a success. As soon as we get confirmation from the queue that the message was received, we take them to a confirmation screen. Yep, we got your order. It's good. It'll be processed soon, right? It's super fast for the user. It's super easy. There's no reason that the user necessarily needs to stick around and wait for us to record the entry, to go do the back and forth with the payment system, all these different things. The user doesn't care. The user just needs to know that their order was received, and we move on with our life. And a lot of shopping cart systems work this way. You don't need to be serverless to do it, but serverless works very naturally with this sort of process. So let's break that down a little bit more. Here's a simple example of a payment system using event-driven functions in a serverless paradigm. This case, the device synchronously communicates with, well, let me, getting ahead of myself. First thing that happens, the user clicks pay. They click pay on their device. What does the device do? The device is going to do a synchronous round trip with our payment system in order to avoid any possible security problems, right? So one thing that we are going to do in payment systems a lot of time is that credit card information, for example, is going to get sent directly to Stripe or Braintree or some other processor. Over a secure connection, it never ever goes to our backend systems. That's really important for things like PCI compliance, for example. They're going to capture that information and return to us some sort of token and say, you can use this token to reference this payment information so that you can conduct a charge, but you don't have to manage that credit card information anymore. Cool. Once that's happened, we're going to submit that message asynchronously to the message queue. As soon as the message queue comes back and says, yep, I got your message, we're not waiting for the message to get processed. We immediately go back to the user and say, cool, we have your order. You're good. Go on about your day. Don't worry about it. Now what happens? Based upon a message getting written to the queue, a couple things are going to happen. We're going to have a service that's going to record those order details to the database. That can be one function that runs. We can have another function that subscribes to those messages that will actually complete the payment transaction. And so what it's going to do is it's going to send all the payment details to our payment service. It's going to say, here's the amount, here's the amount of money that we want to charge. Here's the payment token you gave me earlier. Go ahead and complete that transaction. A couple things about this. It's very important that we do that from a backend system, not the client device. Because if we were to submit payment transactions from the client device, it would be totally trivial for somebody to edit the amount of money that they paid for something just by using Chrome DevTools, for example. So that definitely needs to happen on the server. And we could do that synchronously. We could sit here and wait around for the payment to process, but a lot of payment processors actually have webhook capabilities. So all I'm going to do is say, here you go, hit me back at this other URL when you're done. Okay. And that other URL is going to run a service that's going to record the payment transaction information and add that to our order. Once that's done, potentially, we may have an alert on the browser. Let's say they were watching their orders page, right? They're going to see the order show up. They're going to see that the payment was processed. We're going to update and refresh that view for them, assuming they're watching that part of the database, so that they know things are happening. And this is one way that we can build this with a serverless, serverless ecosystem. And so there's a few things to point out here. So the store order function, it's going to respond. Its precondition is that there's a message that shows up in the queue. Its post condition is that it's recorded the order to the database. There's a charge payment function we're going to create. Its precondition, again, is the message in the queue. Its post condition is that it's sent all the charge information to Stripe, for example. And so we're depending upon a function that sits, it's a third-party function. It's a third-party service. We don't even control it, but we can still document how it works, right? The precondition is that they've received our payment details. The post condition is that they're going to send us a confirmation that the transaction took place. And so these are the types of ways that we will break down the functions that we're composing as we're building our systems. And it's very, very important that we consider the pre and post conditions without side effects. Now, it's possible that a function can do more than one thing. It's not the end of the world, but we want to be very, very careful that we don't create unwanted interactions. All of the things that our function does needs to be very clearly documented as post conditions, and we need to be very careful to set it up in such a way that it only triggers based upon known preconditions. And the reason these things are important is as we add functions into our system that are automatically responding to triggers, we don't want unwanted interactions to mess up the works. So as we're deciding what services we want to build, what services we want to use, how we're going to implement some of these things, I do research. I do research on third-party services that solve the problem I'm trying to solve. I look at backends as a services options. I consider what it would take for me to write my own function. And I compare all of these. I look at the cost to build or buy that solution. I look at the expected monthly operating cost for that solution. And I also look at how long it's going to take us to implement this and get it up and running, right? Because there's a cost associated with that time, but there's also, hey, I want to get this feature to my clients as quickly as possible, for example. So how long is it going to take me to do it? Now, if one approach takes a little bit longer, but it's going to be considerably cheaper, that's fine. But we need to be able to intelligently make those decisions. And another thing we want to consider is any additional requirements that our solution may have. So maybe we need a specific uptime guarantee. So we're going to look at that. We're going to document that. Maybe we know in advance we're going to need a certain amount of memory to be able to do a certain data processing problem. So we need to document that. We need to make sure that whatever we're shopping around for meets the needs of our specific use case. So shopping out feature by feature, excuse me one second. Hopefully you can't hear my system audio. There's a downside to having your phone calls route through your computer apparently while you're on a conference. So hopefully you couldn't hear my phone ringing. So shopping out feature by feature rather than library, framework, or platform at a time can be very interesting. In one case, it actually allowed my parking app FlexiPark to leapfrog every single other product in the market because they were all trying to build their own thing. They were trying to solve their own problems. We shopped around. We found a third-party service that did exactly what we needed and allowed us to build some really powerful machine learning-based image recognition into our system. In our case, we were able to take a photo of a vehicle, send that to a third-party service, and get back as a JSON object the make, model, color, state, and license plate of the vehicle, so that we could do vehicle registration based on a photo. We were the first to market with that. We have a patent on that now, on that capability. And what's interesting is that it was a way of remixing existing services. Competitors tried to do that. They all tried to build it themselves. And what was interesting is I was in a conversation with some investors, and they said, wow, this is really amazing. How big is your team? You spend a couple $100,000 on this, and 10 or 20 people? I'm like, no, I spend $100 a month using somebody else's service. Why am I going to build this when I can buy it cheaply and get it up and running quickly? And that's the type of thing you can do when you're thinking about buying individual features or implementing with existing APIs. You can move very quickly sometimes, and even cheaply. I tend to use Google Firebase and Zapier a lot in my solutions. In fact, I have a talk tomorrow about Zapier and how to use Zapier to do serverless style integrations with different APIs. So these platforms have proven themselves to me in terms of reliability, ease of use, and cost of ownership, but your mileage may vary. You want to analyze your platforms and services based on the way you like to work, your project's requirements, and other types of limitations. Oops. So when you are trying to decide what approach to take, it is worth noting a few specific points. Just because serverless caters to event-driven functional systems and does them very well does not mean you have to be serverless to do this. You can actually accomplish the same thing with monoliths. It may just be a little bit different. So serverless is a great default position for me, but it's definitely not a one-size-fits-all option. And it's my opinion that serverless works very, very well in a UX-first development practice. Last year at Code PaLOUsa, I gave a talk, Serverless for Startups. And in that talk, you may have heard me talk about how I started designing serverless apps basically by mistake, simply because our team worked backwards. We started with the UX and UX research and worked our way backwards. And so as we added services to support the things that we were building on the UI, we ended up being on a serverless platform. So it works very well with the UX-driven approach. And there's a lot more to an API than just REST. Databases, messages, queues, WebSockets, webhooks. There's a lot of different things we can do to build APIs that work well. And so even if we're building a product that depends upon programmatic APIs to other services, we need other developers to be able to consume our services and our data, does not mean that we have to expose that through REST. There's other ways we can expose that capabilities. And one option you may want to consider is an integration platform like Zapier to make it really easy for individuals and companies to provide integrations to your systems. So we have one question: how do you protect yourself from services that might go belly up? And that's a fantastic question. One thing to consider is how significant are they in the marketplace? So for example, the parking service that we're using that does the image recognition for us, they're like the service. There are other services that do vehicle-related data analysis. They are one of the major players in that industry. It's a very important and lucrative industry. And so the odds of them going out of business are very low. And the only way I could see them really experiencing a challenge would be if, for example, Google image machine learning for Google Images. We've got the Microsoft machine learning SDKs, Amazon, IBM. Until we see general purpose image services that are able to offer that same functionality, they're going to be around. And once there's other sources for that functionality, it's less risky for me, right? If they go out of business and I can take that functionality and build it just as easily on Google or Azure, then it's going to take me the time to build that feature, but it's fairly low risk because they're not going to go out of business until somebody else offers something that's competing. So let's say that you have made the decision to build a feature on Azure taking advantage of specific functionality that they offer, and then they decide not to offer that anymore. That's a risk. So there's a couple options. Maybe Google or Amazon offer the same thing you were depending on with Azure. Maybe you move platforms. Maybe you have to change your architecture a little bit in such a way that you have to rebuild some things. So part of it is the fact that you're not building monoliths makes it a lot easier. And the other thing is if you're dealing with event-driven code, let's use an example in some of my applications, because we are not depending upon doing everything in one chunk of code because we're not a monolith. Let's use the photo example. User snaps a photo on their device of their vehicle, and that goes straight to our storage platform. That's the total extent of the user's interaction. Let's say, for the sake of argument, that our image recognition service goes belly up, and it takes me 2 weeks to get something in a replacement. In the short term, we've actually designed our platform that if it takes time for that image recognition to work, we have a backup protocol for verifying, for when we're doing enforcement of a parking lot, for example. We have a visual protocol so that if no match is found in the text-based search of our database, we will present images that have not yet been fully classified to the user to allow them to do a manual process. So there is a manual backup built into our system so that if that classification goes belly up, our system still functions. And so let's say we're accumulating this data for 2 weeks while it takes us that time it takes us to build a replacement to that third-party service. That's just like one little function that exists on a trigger based upon data getting written to a specific storage location, right? So when I build the replacement and I implement that function and I deploy it, it's now going to have data that's out there. It's out there where it's supposed to look. It's going to pull them in. It's going to use the new service. It's going to write the updated classification records, and it's just going to work. It took 2 weeks to run instead of 20 milliseconds to run, but eventually everything became correct. And building systems that are tolerant of eventual correctness is actually one great way to protect yourself from services that may have outage problems, that may go out of business. Breaking your problem down into small functions so that if a service goes defunct, maybe you only have to replace that one function with something else as opposed to replacing your entire system. Those are all ways that we use to protect ourselves. Another option as well, so I use Firebase. I use Firebase for lots of things. I use the Firebase database. But one thing that I do every day is have an automated backup system that will take all of the data in our Firebase ecosystem and send that as a secure backup to Amazon's S3. So that, for the sake of argument, if which I don't see happening, if Google were to decide, oh, we're done with Firebase, no more Firebase, you have 2 weeks to do something, well, that really sucks, but you know what? I can rebuild that on Amazon if I have my data. So it would take some time. I'm not going to say there's no outage, but we wouldn't go out of business because of that. And so you just have to think through your tolerance for risk, how long you can be down for a specific service or a specific offering, and design your systems accordingly. So hopefully that answers your question. So there's two of the biggest differences for me in how I think today versus 10 or 15 years ago about designing systems is that I tackle the user problems first, not the tech problems. I want to figure out how I can help a user, and then I'll apply technology later. I do whatever I can to get to get products, to get designs, to get features in front of them very quickly and prove our ideas, right? We want feedback. We really need analytics. We really need to know, is this going to solve the user's need very rapidly? And part of that comes from me as a business owner and a startup person really going through that mindset, but it really doesn't matter where you are. Being able to serve your users rapidly and well is important in all businesses. The second big difference for me in how I think is I think of designing in terms of events and interactions and less in terms of long-term flexibility, right? Once upon a time, I would build APIs and structures so that, well, what happens if we decide to switch to a different database later? We should probably abstract all these things away, make that really easy. Or yes, we need these things in the API, but I'm going to build these 15 other things into the API so that we can have ultimate flexibility in what types of apps we decide to build. Don't do it. You're not going to need it. There's an anti-pattern called YAGNI. You're not going to need it. And the idea of this anti-pattern is that don't build things you're not going to until you need them, because you're building complexity into your systems. And when you build complexity into your systems in advance without specific requirements or use cases, more often than not, it destroys your maintainability more than it improves your flexibility. And quite frankly, a lot of times we guess wrong. So even if we build flexibility into the system, we might have still guessed wrong about how we're going to need to do it, and we're going to have to build things later. So I think of events and interactions, and I try to avoid building things before I need them so that I build the right thing to serve our needs. Quick example of that, with the parking app that I work on, we offer monthly parking, and I currently do that as a manual process. It's partially automated. The users can submit requests and do things, but ultimately, I actually have to send them a DocuSign link to sign a contract, and then I manually create their subscription. Why do I do this? Because monthly subscriptions generally happen only a few times a year, even though we have a lot of them. Setting them up, it's not something that happens all the time. It's not like a daily thing. It's a few times a month I get requests for monthly parking. Great, I can do that by hand. And I'm doing that by hand so that I learn the process, I learn what it needs to do, because I created a design for that a year and a half ago. And we decided that, you know what, let's do this manually and test it and make sure, let's validate our assumptions. And it turns out almost every single one of our assumptions about how we were going to set people up with a manual parking system, they were all wrong. And if I had built that in code, I would have had to change that. Now I've invested, I don't know, 100 hours of my time over the course of a year and a half setting people up manually, but that 100 hours, I couldn't have built the system, and I certainly couldn't have built it and then fixed it. So now I know what to build. So now we'll be able to invest in building a system that works really well for the users and is easy for them. So by applying these two principles, the user first and events and interactions, serverless has helped me and my team build amazing apps very quickly. One product launch this year called QSaver was released 3 weeks after its concept. So concept, just the idea for the product, to its implementation and its release in production was 3 weeks. Super fast. So these principles have really helped us spend more time on user requests and a lot less time filling with technology and those sorts of things. So any other questions at this point about how I approach serverless, how it's really shifted my mindset from the days of like primarily focusing on monoliths and APIs to primarily doing events and serverless? No? Okay. Well, I will be around and on the chat throughout the conference. So thank you so much for your time and attention. I hope you got a lot out of this. You have a great day. Enjoy the conference.